Uh, Give me one sec. Okay. Hello everybody. I'm Samuel. I am a rising 10th grader in basis, and I've been in the Science Olympiad Club for around 3 years, I think. So yeah, today we're gonna first go over um meteorology, and then we'll do solar system after the break. So yeah, if you have any questions, you can like private chat me, or uh, I would probably prefer you ask like Andrew or some of the other co-hosts. Yeah, Andrew, he's done this event with me, so yeah. Okay, I think I'm gonna start. Okay, so what is meteorology? So meteorology, we all know, is part of science, and it mainly focuses on the natural phenomena in our atmosphere. Our atmosphere being the like layer of gases around our Earth, and there's like many like components to it, I guess. We have daily weather changes, such as like what's the high temperature today or tomorrow, is it going to rain, stuff like that. We have also severe weather, such as hurricanes, thunderstorms, all those types of stuff. And we also have like long-term effects, such as global climate changes, which currently is a pretty significant issue. So in Science Olympiad, uh, there's like three main topics, and we cycle, well, not we, but they cycle through them every year. So on the right, you can see the like cycle, and the topics are climate, everyday weather, and severe storms. So last year in 2022, the topic was climate. But today I'm gonna go over severe storms, because you see here it's been, because of the pandemic, it's been there 2 times in a row. So I have more experience with it, and also frankly, it's just more interesting. Um, the rules. So, meteorology is a study event, so we can have a cheat sheet, which you can see in the of the number 2 event parameters. And the cheat sheet, we can have 2 sheets of paper, and it can be double-sided. So technically 4 sides of notes. You can also have a calculator, which it's not like there's not many questions that will need calculations, but occasionally there are. And yeah, over here in the third section of the rules, you can find all the topics. So this is for the 2020 season, I think, during the pandemic. So you can see all these. There's like yeah, they're all like related to severe weather, because um that was the topic in that year. So you can maybe take a screenshot if you want to look at the rules, or I'm sure you can find it online somewhere. Okay, so although like every year the topics are different, there's always like some basics that you need to know. So some basics are, first, atmosphere composition, such as like what gases make up the atmosphere. There's some chemistry related to it. You also need to know how these gases move and circulate, and how energy is balanced. We have to know some tools, such as measurements. Inside too, these are things such as thermometers, barometers, and anemometers. And we have inside too, they observe things that are like closer to it, and then we have radars and satellites, which are more remote, and they um, provide data from farther distances. And also we have to know the impacts on society. That's really important because that's like the main reason we study meteorology, because we want to predict how it might impact our everyday life or long-term life. So yeah, let's get started with some basics. Um, Atmosphere, its composition, and its layers. So like I said before, the atmosphere is a layer of gases that surround our planet. And um, there's many gases in Earth's atmosphere. Over here, you can see the composition. It's primarily nitrogen and oxygen, but there's other more like trace amounts of gases such as argon, carbon dioxide. And here, water vapor is also or just water in any form is also important because that's what's responsible for many, there's many phenomena. And over here we see it varies because in some places we know it's a bit more dry, so there's less water, and other places it's a bit more humid, so those would have higher concentrations of water. On the right, you can see a picture I found of the layers of the atmosphere. So first on the bottom, we have the troposphere. We're probably gonna mainly focus on this because this is where most of the weather, whether it's everyday weather or severe weather, that's where most of it happens. And then we also have the stratosphere, which is higher, mesosphere, thermosphere, and exosphere. And over here, you can see some numbers on like how high up they are. Okay, atmospheric circulation. So atmospheric circulation is just the large scale movement of air. Like air isn't stationary, so it moves around. And this is caused by Earth's rotation. So it's like everyday rotation around its axis. And also its unequal distribution of heat. So some places will be warmer than others, which causes the air to flow. And then there's three types of uh, global atmospheric cells. Over here on the picture, we can see them on the highest latitudes. We have polar cells, and then in the middle, more like middle region, 30 degrees to 60 degrees, we have the feral cells, and then near the tropics from like the equator to 30 degrees, we have the Hadley cells. And yeah, over here you can also see these colored bands on the Earth. These are just like global wind belts, just generally how the wind moves around. And so up here we can, well, let's start here. We see these are called westerlies, and basically winds are like named by which direction they go. So you see these arrows, they point to I mean, not which way they go, where they came from. So we see these arrows, they start from the west and then they point east. So that's why they're called westerlies. And wind will blow from high pressure to low pressure. So yeah, you can observe these wind cells if you want. I won't really cover them too much in detail. So yeah, now let's move on to clouds. So clouds are visible masses of tiny water droplets in the air. And these are formed by condensation, which is part of the water cycle, which I'm sure many of you are quite familiar with. And to classify these clouds, we have many different categories, I guess. We can look at their shape, their thickness, and their altitude. So over here, you can see like many of the clouds, you can see how they're based on different altitudes, maybe different shapes. You see not all of them look the same. So yeah, let's start with the low level clouds. So these clouds are found under 6,500 feet. And the main types are cumulus. These clouds are fluffy, such as the ones in the background. And these generally signify stable weather. We also have stratus, which are like layered clouds. They look gray, but there's not too much precipitation. We have stratocumulus, which by the word you can see it's a combination of stratus and cumulus. And we also have nimbus clouds. And nimbus in Latin, I think it means rain, rainstorm. So these are clouds that have precipitation. Okay, the middle level clouds. These clouds are found between, so just above the low level clouds at 6,500 feet and up to around 23,000 feet. These ones all have the prefix alto, which means high in Latin. So these are relatively high in the atmosphere. And we first have alto stratus, which is alto plus stratus. So stratus clouds that are higher. We also have alto cumulus, which are just cumulus clouds and just slightly higher. They're patches. And yeah, in the background, I think these are alto stratus. So you can see how they're thinner and more like layered, I guess. Finally, we have the high clouds. These clouds are like super high up in our atmosphere, well, in our troposphere, and these are above 23,000 feet. And they mainly all have the prefix cirro, which means wisps in Latin. So we have the cirrus clouds, which you can see in the background. They're just thin, they're light, they're like wisps of clouds. We have cirrostratus, which are just stratus clouds, but even thinner and higher. And we have cirrocumulus, which are just cumulus clouds, but much lighter and wispier. And we also have these multi-level clouds. These clouds occupy many levels of the atmosphere, so they can be in the low level, the like mid-level, I guess, and the high level. And one such as the one you see in these pictures, these are called cumulonimbus clouds. These are very massive clouds, and you can see they kind of have an anvil shape. And these clouds have heavy precipitation and often signify thunderstorms. So yeah, does Math have a question? Um, I if you're talking, I cannot hear you. Maybe you can try typing it in chat or send it to Andrew or the other co-hosts. So yeah, I'm gonna just move on. Okay, atmospheric pressure. So I'm sure you've all heard of pressure. Pressure is just defined as force over area. So atmospheric pressure is how much pressure the um, atmosphere exerts in this column of air. So you see like over here, there's a diagram. In this area of 1 square inch, we have like just air over us. So there's this air that's putting weight on us. So you might not notice it, but there's weight, air has weight. And yeah, as you're lower, obviously there's more air above you, so the pressure will be higher. So there's many units to pressure, such as atmosphere, pascals, hectopascals, millibars, millimeters of mercury, PSI. And one reference we use is sea level pressure, which is when our altitude is, um, can you please mute, please, whoever that was? I don't know. Anyways, yeah, this is the reference we use when we're at sea level or when the altitude is 0, so like at sea level. And so over here, I just listed a bunch of unit conversions for the sea level pressure. So maybe have a look at those. They're they're not too important, but it's good to know anyways. So yeah, um, PSI over here, 14.7 PSI at sea level. PSI stands for pounds per square inch. So over here, if you look at it, if we're at sea level and the area, the column is 1 inch squared, that means there is 14.7 pounds of air above you, which might be, you probably like don't really realize it, but yeah. Okay, let's go over some tools. So we have all these various types of tools to study the atmosphere. First of all, we have like the inside two, which are like thermometers, barometers, which measure pressure, and nanometers, which measure wind speed and direction. And these ones are all on the surface, so you can find them over here at the automatic station, or you can uh or maybe at the surface station. These are all on the surface. We also have these instruments are attached to balloons. These are one such is called radiosonde, and these, what they do is as they because they're attached to balloons, so they will ascend into the atmosphere, and then they can measure the pressure, the temperature, and humidity. And we also have radars, like this one over here. Radars, they send out pulses of high frequency um, electromagnetic waves, and then these waves are reflected off the object back to the radar so they can study it. We also have satellites up here. Over here, we see a polar orbiting satellite. That just means it goes from north to south, so it passes the North Pole and the South Pole. We also have a geostationary satellite, and these move at the same speed of Earth. They like move around the same speed as move around Earth at the same speed. So relatively, they're not moving at all. And then all the information from these various types of tools, they will go back to the NMS, which is National Meteorological Service, or maybe some other meteorology related services. And then, yeah, so scientists can study the data collected. Okay, let's move on to severe weather now. So, like I said, this is I'm mainly going to cover severe weather because it's one of the main topics for Science Olympiad. Over here, we see the main types, such as a thunderstorm, tornadoes, hurricanes, windstorms, and yeah. A big reason we study severe weather is not just because it's entertaining or because it's like interesting, but it's also really important for safety. So we know how to react when we may potentially encounter one. Okay, let's start with thunderstorms. So thunderstorms, they, if you look over here at the structure, you can see this is a cumulonimbus cloud. And the ingredients for a thunderstorm are it needs to be moist and warm. The air must be unstable and rising, and there must be a lifter of this air. And then there's many thunderstorms, and they become severe when you meet um, one of these requirements, when there's more than 1 inch of hail, when the wind speeds are greater than 57.5 miles per hour, or when a tornado occurs. So yeah, over here we have the types of thunderstorms such as single cells. These are relatively weak storms. They're more brief. We have multi-cell, which basically means many cells, but each of these cells are at different times in their life cycle. So some might be just forming, others might just be like dying, I guess. And then we have supercells, and these are the most dangerous. These are huge rotating updrafts called mesocyclones. And yeah, these are the most important. And not most important, most intense. So if you ever encounter thunderstorm, some safety, you probably want to stay inside a sturdy building. If you're outside, just try to find a sturdy building and try to avoid open spaces such as like I don't know, like a field or something. Also, don't go up to like high ground, like on a hill or something. You also stay away from bodies of water because those will probably make the thunderstorm more intense. Okay, tornadoes. So tornadoes are um, basically these vortexes, and they look like a funnel, and they can move around really quickly, and they're very destructive. So the ingredients, it needs a strong updraft, which is just upward movement of air. It needs wind shear, which is basically at different altitudes, the wind speeds are moving at different, the wind is moving at different speeds. It also needs moisture at the base, instability, which is kind of wind shear, I guess. And yeah, the winds have to be really fast. And these tornadoes, they mainly form from supercells, which I covered last slide. These are the most intense thunderstorms. And to like categorize these tornadoes, we have the scale called the enhanced Fujita scale. And this scale takes into account the damage and the wind speed. So on the top right, here's like that's just the scale basically. You see at EF0, which is the weakest level, the winds are from 65 to 85 miles per hour, and there's light damage. But once we get to EF5, which is the most intense, the most severe, the wind speeds are over 200 miles per hour, and there is incredible damage. So yeah, some safety for tornadoes. You want to try to find lower rooms or rooms without windows. If you're in a car, just try to find lower ground. Well, actually, you shouldn't drive around, but if it's really close, you can try to find like a ditch or something. But if you're just on like the open road or something, just stay in your car and cover your head and keep your seatbelts fastened. And yeah, so these tornadoes, they mainly come from the supercells, and they also mainly form in in America, they mainly form in the Great Plains, which I'm not sure if you know the American geography but that well, but these are areas such as in like Iowa, South Dakota, like near the middle of the United States. So yeah, you're not likely to encounter one near the coast, such as in California. I don't know where you guys live, so yeah. Okay, hurricanes. So these are basically huge cyclones that form over the ocean. And the ingredients has to have warm water of greater than 26.5 degrees Celsius. So you won't really find hurricanes in higher latitudes near the polar regions. And you also need a low vertical wind shear. So the winds, they can't be like too contrasting in different altitudes. They have to be relatively the same. And over here, you can see a structure of the hurricane. In the center, we have the eye. And the eye is actually the calmest place of the hurricane. There's not much winds, not much rain. So it's quite calm there. But around the eye, we have the eye wall. And the eye wall is the most devastating part of the hurricane. There's high winds, heavy rains. And then around those, we have rain bands, which are slightly less intense than the eye wall, but there's still lots of rain. So the greatest hazard of a hurricane is storm surge, which is just coastal flooding. And it also, some other hazards are um, high, high winds and heavy rainfall. So over here in the top right, you can see the scale for hurricanes. You know, we had a scale for tornadoes, so there's also one for hurricanes. This is called the Saffir-Simpson hurricane scale. And yeah, you can look at those categories. It's quite similar formatting to the hurricane scale. So yeah, if you ever encounter a hurricane, if you live near like, I don't know, Florida, those areas, if you're inside, just don't go outside if like you're in the midst of a hurricane. If if you receive a warning, you should probably evacuate, know where to evacuate. Like in a tornado, take cover in an interior room or the basement. So yeah. Here we have, I found some photos of some severe weather, and these are taken by radar and satellite. So the two pictures on the left, um, these are radar pictures, and this bottom right one is satellite. You can tell it's radar since um, I'm like, because satellite, it basically just images the storm from above. But radars, they send these electromagnetic pulses, and then they can see the structure and stuff of it. So over here in the top left, we have um, a radar image of a thunderstorm. So yeah, we see the more redder colors, such as red and pink. These are heavier rain, and the cooler colors, such as blue and green, these are lighter rain. I don't know if you didn't see my mouse, but over here on the bottom left dish of the hurricane, I'm not hurricane, the thunderstorm, we can see like this hook figure. This is called a hook echo, and it signifies a tornado. And yeah, so on the bottom we have a hurricane. You can see like its cyclone feature, and you can also see what a hurricane looks from above. So you can see they're quite massive. They basically, their like width, I guess, is almost probably greater than half of the length of the Gulf of Mexico. So yeah, these are pretty massive. And tornadoes, on the other hand, they're much smaller. Okay, now we have some winter storms. So these are storms with snow, sleet, or freezing rain. And the ingredients for these storms are the air must be cold, it must be moist as well, and there has to be some lift. So the main types of storms are, first we have blizzards, which is just blowing wind and snow, and there's low visibility. So if you see in the picture here, you see all this, there's all this snow and it's blowing around, so it's hard to see. We have ice storms, and we also have lake effect snow. You can read those. There's not much time for me to cover them. And so there's many hazards to a winter storm. We have car accidents because, first of all, the roads aren't clear because of snow, and also it's hard to see because of the blowing snow. We have hypothermia, which comes from cold weather. So yeah, heart attacks also from cold weather. There's also carbon monoxide poisoning, and this mainly happens when gas appliances such as like heaters or like the car exhaust, they malfunction, and then the gas travels into the room, and the gas is toxic and not safe. So yeah, if you're ever in a winter storm, I don't know if anyone's living up in the northeastern of the United States, just make sure to prepare clothing, food, and water. And yeah. So over here we have the winter precipitation, and these will result. These will come in the winter storms. So first we have snow. I'm sure you all know what snow is. These are just tiny ice crystals. And if you look on the top right image, this image describes snow, because as long as the as it descends, you see like this blue line. This basically says the temperature. As long as this blue line is less than 0 degrees Celsius or less than freezing, it will always be snow. And then in the middle picture, we have sleet. And so at first we see in like between 3 and 2 kilometers in the atmosphere, we have the snow, just like in the top one. But then it will go through this shallow warm layer. Yeah, it'll go through this shallow warm layer, so it will um, partially melt, but not like completely melt. And then it'll go back through a deep cold layer, which it will, the partially melted snow will then refreeze and then become sleet. And then on the bottom, we have freezing rain. So at first it's snow, snow, but then it goes through a deep warm layer, which makes it melt completely. So now they're water, and then it will go back into a shallow cold layer. And then once it hits the surface, they will instantly refreeze and become freezing rain. So one type of freezing rain is called black ice. And this is dangerous because the ice isn't black, but it's basically completely transparent. So if you're on the road, you know how the road is black, so the ice will look black and it's hard to see. And then if you're driving over it or walking over it, it's probably very slippery, so you have to watch out. So yeah, let's do a Kahoot now. There's not much time though, but yeah. Mm, yeah, feel free to join.
Hey Samuel, can you send a link in chat? Like just like copy and paste it? Like if you just like hover over the game pin and like click it, I think you should be able to like yeah.
Oh, okay, I can do that. Um,
Whoever is it named Samuel L in the Kahoot, you're very funny.
so yeah, I'll probably start as soon. There's not much time left. I think we can start. You can still join if you're um not already joined. In which layer does most of the weather phenomena occur? Yep, the troposphere. Good job. What is Earth's atmosphere primarily made of? Yep, nitrogen is around 78%, I think. Nice. Which atmospheric cell is found at the most northern or southern latitudes? Ferrel, Hadley, polar, or trade winds? Yep, polar. I mean, its name kind of gives it away, the poles. Which best describes a nimbus cloud? I think we'll do like 2 more questions after this because it's already break time. Rain, nimbus in Latin means rain or rainstorm. So yeah, good job. What is the sea level pressure in millimeters of mercury? Yep, 760. Um, yeah, I don't know how to explain this.
This is just something that's really useful to memorize.
Yeah. Yeah, I'll do one more question. Which of these conditions means a thunderstorm is considered severe? Maybe not the best question wording, but yeah. If there's rain, is it severe? If there's 50 miles per hour wind, is it severe? If there's 1.5 inches of hail, would that be considered severe? Or maybe if it's snow. So yeah, it's 1.5 inch hail. So remember the 3 conditions are first, if it's greater than 1 inch of hail, which you can see in the yellow answer, if it's greater than 57-ish miles per hour wind, but this 50 miles per hour is less, and these two are irrelevant because the last condition is if there's a hurricane or not. So yeah, I think we'll stop it there. I don't know how to stop it. Okay, we'll do one more. What is the most common scale that we use for tornado intensity? Is it the Fujita scale, the E Fujita, the Saffir-Simpson, or the Beaufort? Yep, it's the enhanced Fujita. Okay, okay, yeah, I'll just end the Kahoot now. Good job, Blair Bun. 7 out of 7, which is good. Ian for the win. I mean, not quite the win, but it still did quite well. And bro. And good job to Xenon and Madison as well. So yeah, it's a bit over time, so let's just take our break right now.